Okay, I'm not capable of a lot, but I can read a clock, and it says 5:14 and 58, 59, 5:15. It's time to start. Thank you all for coming. I appreciate you all braving the rain. It looks like the worst of it swept through just before we got started. We've got a couple administrative comments. Next week's lecture is Barbara Tieran from the Electric Power Research Institute. She's going to be talking about Grid Next, some of the research and studies they've done on future models for the electric utility, not so much the business models, but the grid structure to support extreme high penetration of distributed and renewable energy. So that'll be next week's talk. I think you'll enjoy that. Any concerns from the students on administrative stuff? I think for the first time we actually graded some stuff and posted some grades. Yeah, nobody wants to stick their hand up in front of everybody else. If you have any concerns about any of that, come see me or Carrie, preferably Carrie. But no, nothing to worry about there. It is a pass-fail class, credit only, but we do have some criteria, and if you feel you didn't quite perform to what our expectations were on something, just come see us and talk to us so we can explain what's going on, but nobody's failing the class. For those of you who aren't taking it for a grade, never mind. Okay, tonight we've got a very great pleasure. We've got an alumni. Colin Meehan is an old friend and colleague. Colin and I met working with the Weber Energy Group, 5 years ago, 6 years ago? It doesn't seem like it's been that long. He got his undergraduate in some hoity-toity little New England school. I can't remember the name of it. But more importantly, he got his master's here at the University of Texas Austin in the Energy and Earth Sciences program. So this is what you can grow up to be if you're in the ER program. Colin has worked in a lot of places here in Texas. He's part of the social network in energy here in Austin. He's one of the usual suspects at all the events that most of us go to. It's like clean energy beers and whatnot, and green drinks. He's worked a lot of places around town. He's worked for the LCRA. He's worked for the Environmental Defense Fund. He's worked for 2 or 3 others that I can't remember, but those are the important ones. And now he's at First Solar. He's passionate about this stuff. He's been engaged in this area, this arena, for quite some time, and I see no end of that in sight. There's great things on the horizon for solar in Texas. I think a lot of us understand and believe that, and Colin has kind of been the forefront of it. He specializes on the regulatory side of things. He's kind of an engineer and a scientist like the rest of us, but I think his real expertise is in the policy side, and that's where he really enjoys working. I think he's kind of found a home at First Solar. I think you've been there longer now than you've been just about anywhere. So apparently it's working out, or at least they haven't figured him out yet. I think you'll really enjoy the talk. Afterwards, he has agreed to join us for some after-talk adult beverages and snacks, and he chose the location, not I, so it's not Schultz Garden. We're going to be at the Hole in the Wall, which will be new for me. I've never been there. I'm looking forward to it. Yeah, I know. I've driven by it a million times. I've just never somehow been pulled in. So we'll join up over there probably around 6:30, 6:45, if any of you want to join us and continue the conversation. With that, Colin, I hand it off to you.
All right. Okay, it's working. Well, thanks for that introduction. I've got a little bit more about my background here. I am not an engineer, actually, Fred, despite what he is saying. So I'm gonna talk a little bit about the technology behind solar panels, in particular First Solar's panels. But how many folks here are in mechanical engineering or electrical engineering schools? Okay, yeah. So you guys are going to tell me when I'm wrong. EER grad students? Okay, good, yeah. Do we have like a chant or anything or some secret code? I don't know. No. Yeah, right, the handshake. I'm going to talk, so First Solar is a utility scale solar developer, a photovoltaic panel manufacturer, and I'm going to focus primarily on the utility scale solar market. So that's ground mounted installations, generally speaking somewhere above 20 megawatts, although it goes as low as 2 megawatts and in some cases even lower. Really depends on what market you're in and what issue you're trying to address. Happy to answer questions. Obviously, I'll leave time for questions at the end. I've got a lot of slides up here. I'm probably going to run through some of them more quickly than others. But again, if you want to join us for a beverage afterwards, I'm happy to talk about any of this. First about First Solar, we partner with all kinds of companies throughout the U.S. and internationally. We are the largest U.S.-based solar panel manufacturer. We have manufacturing in Perrysburg, Ohio, which is outside of Toledo. I didn't know where Perrysburg was, but I got to go there earlier this year, and it's very interesting. I'll talk a little bit about our manufacturing process in a second for those that are interested. I'm guessing some of you are. But we partner with utilities typically to develop utility scale projects, and I'll talk about why. There are a couple reasons why we've focused on that market as a company. A lot of it has to do with our technology, and then a lot of it has to do with the regulatory space, which I'll probably spend the most time on because that's what I actually know. The rest of this I don't actually know what I'm talking about. So. We as a company, we run the gamut. We're essentially a vertically integrated solar company. We do everything from greenfield solar development, engineering, obviously panel manufacturing. We do finance, we finance projects. We do the balance of system, installation, engineering, procurement, and construction. What else did I forget? Oh, operations and maintenance. That's actually really important. So solar panels or solar power plant operation and maintenance is obviously a growing field. We've got a lot of utility scale projects going in throughout the world. We have the largest fleet of utility scale solar power plants under our operation and maintenance. Most of them are our power plants, but not all of them. So we also manage other people's power plants, sometimes even with different panel technology as well. So First Solar manufactures a thin film CAD-TEL based solar panel. And the reason that we do that essentially is because it's a more cost efficient method of manufacturing. As you can see, it's a pretty cool deposition process, relatively simple to a guy like me who is not an engineer, relatively simple process. You can just walk through the factory floor and kind of follow it as it goes along, and it takes about 2.5 hours to go from a plain sheet of glass to a fully operational solar panel with the little connectors on the back, and you can just hook it up. Silicon-based solar panel manufacturing, and this is not, I'm not here to like knock one technology against the other or anything like that. I just want to talk about how the different technologies work and what the benefits and differences are between the two. With silicon-based panels, you have to grow a silicon ingot, or a silicon crystal, and you slice that into a wafer. Then you take the wafer and oftentimes you'll ship it to a different manufacturing facility. So it's essentially a batch process, a batch manufacturing process. And that ends up taking a bit more time, a bit more energy. But on the flip side, especially if you have monocrystalline silicon panels, so a single silicon crystal for that panel, the efficiency of that panel is generally higher than the efficiency of our thin film panels. That's starting to change. As you can see here, let me get my pointer. So this is where our test efficiency is for panels now, 22.1%. You can see how much we've changed since 2011. Over 5 years, we've grown from, and again, this is test efficiency, from about 16%. We've added another 6% onto that. That's a tremendous growth, and you just really haven't seen that kind of growth in either the multi-crystalline silicon or the single crystalline silicon panels. I feel like I'm talking a lot about solar panels. I hope this is interesting to you guys. I mean, this is, I guess, the reason here is just the theory behind it and the financing behind it really is the efficiency of a panel tells you how much energy output that panel will provide per square foot, inch, whatever, meter, if you're going to be, metric about it, accurate as my father would say. So what that means is for the same manufacturing process, the same square meter, if you have a greater output of energy, you have a greater opportunity for revenue, for long-term revenue. And ultimately what it does is it reduces your cost per kWh, cost per kilowatt hour. And that's what I'm going to talk about a little bit later. And that ultimately determines a lot about the potential for success in the solar industry, whether it's rooftop solar or utility scale solar like this. So the other thing about First Solar is, and in particular CAD-TEL panels, and one of the reasons that we focused on this technology is, for reasons that escape me as a non-engineer, we have a higher theoretical efficiency than silicon-based panels. Silicon-based panels, I believe, their theoretical efficiency is somewhere just below 30%. And ours is somewhere in the 35% range. And what that really means is we have a lot more room to grow, and with the same or even lower cost structure, whereas in general, multi-crystalline silicon probably has a lot more room to grow. Single crystal silicon definitely does. But with that growth comes, I think, an additional refinement of their processes in a way that may add additional costs. And again, the market will figure this out. I think all of these different technologies are going to have a great role to play, but I just thought that was an interesting distinction. And also I should note, we're the only major thin film panel manufacturer in the world, really. We are, I think, 10% of the international market, which for a single company is a lot. And for thin film solar, that's probably a small, for a different type of technology, it's a relatively small percentage, but for a single company, that's very substantial. So this is where the dollar per kWh, and I apologize, this is kind of tough to read, but I would really, if you folks are interested in the economics around solar or renewable energy in general, or just the generation fleet more broadly, I would highly recommend that you look into Lazard's levelized cost of energy analysis. It's a fantastic analysis. They update it every year. It's a very brief presentation. It's literally, I think, a slide deck like this, and I just kind of copy and pasted the table out. And it's fairly up to date. It's more up to date than, for example, the Energy Information Administration data, which is woefully out of date. More up to date than the EPA's data, which is better. More up to date than ERCOT's data that they use here to do their analysis, which is even better. This is what I tend to think of as being the most accurate when it comes to the economics of rapidly changing and evolving technologies, in particular solar, wind, to a certain extent geothermal, fuel cell technology, that sort of stuff. I think they do a very good job of it, and they also, I think have pretty reasonable estimates on more conventional generation. So, gas combined cycles, et cetera. This is obviously the big red circle is where we are. This is thin film utility scale. You can see that, and again, this comes down to our cost of manufacturing on a dollar per kWh basis. Utility scale solar in general is the most cost effective type of new generation for, I guess I should say, during on-peak hours. Wind generation obviously can be more cost effective depending on the resources. And of course it depends on how the resources look for solar as well. So this is all based on essentially optimal solar resource. So the southwestern US, wind I believe is based on the midwestern US, the wind corridor up through North Dakota. But what this shows is that we're now in a place, and we haven't been in this place for very long, it's really just been about maybe 2 years or so, where utility scale solar can compete toe-to-toe against the conventional type of generation if you're looking at building new capacity. And that's fascinating. I'll also note this is the unsubsidized levelized cost of energy. So this backs out the investment tax credit. It does not back out a lot of the different tax treatments and tax credits that are sort of baked into the tax code now for a lot of other technologies. That's something that comes up occasionally in my work. So what does this mean? Ultimately, you're seeing more and more. ERCOT is a great example. Excuse me. They do a long-term system assessment every 2 years where they forecast out what they expect to happen over the next 15 years. They're due to have another one out very soon, and I didn't want to put that data up because it's not official yet, but it shows an even stronger trend for solar growth. But we see here in 2013, 0% of solar growing to 10% by 2027. This is all based on economics. And this is actually part of a process that I and some of my colleagues in the solar industry, like Charlie Hemmeline here, the executive director of the Texas Solar Power Association, we spent a lot of time with ERCOT staff, and the Electric Reliability Council of Texas. Has everybody heard of this? Has anybody not heard of the Electric Reliability Council of Texas? I guess at this point nobody's going to raise their hand, right? They run the grid in Texas, and they also look into forecasting. They basically do these kinds of analyses to try and determine what type of transmission needs and other infrastructure needs we're likely to see over the next 15 years. Historically, they were seeing no potential for solar growth, and that was based on the cost and their cost projections, which were about twice what they are today. But after looking at more up-to-date data, they've been able to adjust those projections, and now you can see that solar, again, this is without any changes in policies, this is without the Clean Power Plan, without an extension of the investment tax credit. Solar is going to grow pretty rapidly over the next 15 years. And this is just a chart. If I do a presentation, I always have to throw this in. It's a rule of mine. This just talks about, this is to demonstrate, there's a great study from the Lawrence Berkeley National Labs that looks at the geographic diversity in utility scale solar installations. And what this shows is when you have a single location, you do actually see some intermittency, and that can have impacts for the grid. But when you start to build more and more solar projects and they're dispersed over a relatively small area, I can't remember the exact area, I don't think it's up here, but you can certainly find it in the study. It substantially reduces, I think the number is approximately 85%, it reduces that sub-hourly variation in solar generation. So this is to say, if ERCOT goes from 0% to 10%, it's not like that 10% is going to be going up and down every day as a cloud goes over. It's going to be geographically dispersed, and it'll actually be a relatively smooth and predictable curve. All right, market structures and utility scale solar. This sounds super exciting, I know. This whole, my titling is very literal today, but this to me is one of the most fascinating issues about affecting how utility scale solar and solar in general is going to develop throughout the U.S. We have a total patchwork of regulatory structures. Some of you, maybe folks, if you've taken some of the classes at the business school or LBJ, are probably a little bit aware of this. I highly recommend, I can recommend a number of classes for EER folks if you're interested, but energy law, I think, talks a lot about this. I believe Dr. Rai has a couple of classes that talk about different residential solar markets throughout the U.S. But we have these organized wholesale power markets, and each of these colors is a different one, and each of them have their own different regulatory schemes, and within each of those, every state has their own different makeup. So you could have a deregulated state, you could have a vertically integrated, regulated state, like Virginia, for example, that has an independently owned utility. They have a monopoly over all the customers in their state, but they sell into what is essentially a competitive wholesale market. It makes things really confusing, and basically it can make it difficult, not just as a solar developer, but any business trying to bring new generation. It can make it very difficult to bring that to market in these different regions simply because of that confusion, and in particular, that's driven today by the low price of natural gas. So where you've got these organized wholesale markets that are driven by a marginal clearing price of energy, so whatever the price of natural gas is, sets the price for energy in that region. Right now, these were all developed at a time when natural gas prices were at $5 and expected to go to $10, right? And what is it today? It's probably $3, or maybe even a little bit less, I don't know. But it's been in the $2.50 and slightly lower, slightly higher range for the last 2 years. And what you're starting to see are some substantial coal retirements. You've probably heard about nuclear plants retiring. These are base load plants that have a relatively low cost of generation, but because these markets are driven by natural gas prices, it's throwing them out of the market, and even some gas plants are retiring. It's even too cheap for gas plants to run. This makes it complicated to develop solar in those markets. So those are the organized wholesale markets, and they're regulated by the Federal Energy Regulatory Commission. And then, as I said, different states have different stages of deregulation. This is from the Energy Information Administration. If you look up EIA deregulation, literally, if you just type in those two words, this is what will show up. And it's a great resource. You can click on each of these states, obviously not here, but it'll tell you a little bit more about what's going on in those states. In some states, you've got, again, a vertically integrated marketplace. The Southeast is probably the best example of this. Every utility has a monopoly. If you live in Florida Power and Light's district, they're the only one you can buy your power from. In Texas, if you live in Austin Energy's district, as I do, they're the only ones I can buy power from. But if you live in Round Rock, you probably have, 30 different companies with each of them 15 different plans that you can buy power from. That has benefits. That also has, some downsides to it as well. So Texas and ERCOT in particular are what I tend to go to when I talk about deregulation. We have kind of the full Monty of deregulation. That's probably a terrible analogy, but we have restructured our wholesale markets so that power plants have to compete against one another, as opposed to a monopoly utility that simply goes to their local commission and says, I would like to build this power plant, and the commission says, you can build that power plant and you can get a 4% rate of return on that power plant. In Texas, if you want to build a power plant, you have to go to a bank, or if you've got the money, you can build it yourself, but you have to go to somebody generally and say, I want to build a power plant. Here's why I think we can make money in Texas. Here are the market fundamentals of the state. It's a competitive market. Natural gas prices are here. We think this is what's going to happen over the next 10 years. Maybe natural gas prices go up, or maybe we have a substantial amount of old power plants that retire. And based on that analysis, you have to find out whether or not you can build a new power plant. That's the same kind of analysis that a utility scale solar developer goes through. And that is exactly what we have to go through, in particular in all of these competitive states with competitive wholesale power markets. And these are most of the green states and some of the yellow states as well. If we're working in the Southeast, for example, or some of these other states, Nevada is actually an example of one where we just go to the utility, or the utility actually goes to their commission and says, we want to build new power plants. We've done the research, and this is becoming very, very common. We've done the research, and we need peak power. We need power during the daytime, and we actually think that utility scale solar is the best way to go. We think it's the most cost competitive, and so we want to build 200 megawatts of solar. Or like Georgia Power did earlier this year, we want to build 1,600 megawatts of utility scale solar power. And they have to convince their commission. And sometimes my job is to go in, not necessarily hand in hand, but to go into the commission as well and say, do you have any questions? Would you like to talk about utility scale solar? I can talk to you about the cost. I can talk to you about the technology. And then the regulator ultimately approves that and gives the utility some sort of a rate of return on that. So those are kind of the two major structures that exist. In addition to that type of competitive market, there's the retail side, which is what I was talking about with your electric bill. So states that have retail competition, Texas, Illinois, New York, Pennsylvania, there are a few others. I can't remember off the top of my head all of them. But with states that have retail competition, that utility that wants to build the power plant doesn't have the sole exclusive right to sell you electricity. They basically have to compete for your business. And that's great. I mean, that leads to an incredibly competitive marketplace that allows the customer to make a lot of decisions. You as a customer can decide, I want to buy 100% renewable energy. You can decide, I want the lowest rate possible, and I don't care if it changes next month because I'm going to look into changing it next month too. You can make a lot of different decisions about how you consume electricity. Ultimately, most customers are not the kind of customers that are going to manage their bill on a month-to-month basis. So that kind of switching doesn't happen that often. And it took a long time, even in Texas, for customers to switch off of their incumbent utility. The old TXU Energy was the incumbent utility for the Dallas-Fort Worth area. I can't remember the exact numbers, but I think even in 2007 or 8, well after retail deregulation had been in place, I want to say 30 or 40% of their old customers were still their customers. Maybe even more. I could be totally wrong on that number, so don't quote me on that, even though this is being filmed. So all of that's kind of the groundwork. This is the market. These are the markets in which we as a utility scale solar company have to operate. We look at a state and we say, what does the market look like? Is it competitive? Is it deregulated? If so, is it a market that we can build in? Do the power prices support our investment in solar power? And if it's not vertically integrated, if it's not deregulated and unbundled, then we have to say, what does the utility look like? Are they going to need new capacity? Is their commission open to solar power? If they're not open to solar power, do I need to go there and not like I can change any minds or anything, but at least try and educate some folks, and say, hey, do you have concerns about solar? Let's talk about that. What are those concerns? How can we address them? There is still a need for a lot of education in that space. A lot of utility regulators are starting to learn more about solar, but some still think of it as a kind of a technology that might be interesting in 2030 if you're a hippie sort of thing. So there's still some work to be done there. Renewable portfolio standards play a big role, in particular in these wholesale competitive markets, in making it easier to build a solar power plant, at least right now. I think that role is evolving and probably in a lot of states is going to essentially go away for a variety of reasons. But renewable portfolio standards set a goal for a state. The legislature or the Public Utilities Commission says you as a state need to have 10% of your electricity come from renewable energy, and of that, maybe 5% or whatever comes from solar. And when they set a goal like that, it makes the market much more clear to us. This is an important thing. I mean, usually a regulatory intervention like this, there's a very strong argument in, just sort of conventional economics that any regulatory intervention is going to increase costs. That hasn't really been the case with RPSs. You can probably argue it either way, but I think there's a lot of good information out there that demonstrates that hasn't been the case. Happy to talk about that over drinks if you want to argue with me. What it does is it allows us, if a company is going to a bank or if we're trying to finance something ourselves, we look at that state and we say, what does the market look like? Okay, it's a competitive market. What's the price of power in that competitive market? Let's say it's $40 or $50 a megawatt hour right now. And what about the RPS? Do they have an RPS? Is it 5%? Okay, they have a 5% solar RPS. How much solar do they already have? They're at 4%. Does our solar power plant still fit within that RPS? So is there demand for more solar in the state? And that demand is tied to an associated shadow price or renewable energy credit that allows us to understand whether a project is financeable in a state or not. So that renewable portfolio standards have played a really foundational role in growing utility scale solar throughout the US. An even bigger role in wind, but I'm obviously not here to talk about wind. But they've been very important. I think that importance is going to change, especially over time as we evolve into hopefully a country, but certainly regions that have different forms of carbon pricing. They may, I don't know if they're necessarily going to be a one-for-one trade-off, but I think it's going to change the role of RPSs in that discussion. In vertically integrated states, and I've already talked about this, so I'm going to just go through it really quickly, but they go through this integrated resource planning process. Again, they go to their commission, they say, we're going to have, our customer growth is 2% a year, so we need to build new power plants to meet that demand. And again, we think it's peak power that we need, so we think it needs to be solar. Maybe it's not peak power. Maybe they need baseload power. Maybe they're arguing for a new nuclear plant. Very few, I don't know if any utilities now are advocating for new coal plants. They're simply not cost effective. If we went back to that chart on the dollar per megawatt hour, I think coal is somewhere around $90 a megawatt hour for a new coal plant. A new solar plant is somewhere in the $50 to $70 range, and even a little bit lower if you've got really good siting. So in those states that have those kind of processes, because solar is cost competitive now, the renewable portfolio standard doesn't really play as much of a role. You don't see any renewable portfolio standards in the Southeast, and that's mostly because of politics. The farthest south they go is North Carolina. But again, in Georgia, they just built over, I think, 800 megawatts, and they're planning to build 1,600 more megawatts of solar. And that's because they have this regulated process that they go through with the commission where we just kind of lay out the facts and say, here is why you need to make this investment. That gets approved, and we move forward. This is, I'm going to go to the next slide, sorry. This was a last-minute addition. I can't believe I didn't include this earlier, but corporate renewable purchasing has become really critical in renewable energy, both for wind and solar, particularly for utility scale. So over the last couple of years, as the price of natural gas has gone down, there's been a little less interest from power, and actually I should say the cost of solar came down pretty dramatically over the last couple of years. Utilities bought up a lot of solar, and there's been a ton of expansion in 2014 through this year. And now utilities are saying, okay, we think we're good, we maybe need a little breather. But all these companies are saying they want to only have renewable energy in their portfolio. They want it to be a significant part of their portfolio. So back in 2008 and 2009, companies like Walmart, Google, Facebook, Microsoft started setting these sort of arbitrary and a little bit vague goals of wanting to have renewable energy. This is starting to get very real now. And what you're seeing is they're advocating in different states for different approaches to being able to buy renewable energy. If they're in a vertically integrated state where their utility is their sole monopoly provider, it can be more difficult because they have to go to their utility and say, hey, I'd really like renewable energy. I want it to be a new power plant. That's always important to them. They don't want to just buy something that's already existing. They want to have an impact. That's a very important thing to most of these companies. So the utility has to then say, yeah, okay, we'd like to do that. That seems reasonable, but we need our return on that as well, just like we would on a normal power plant. Obviously, the corporates don't generally like that. They don't want to give any additional return. They don't just want to feel good. They want to get the best deal they can. In deregulated markets, it's much easier where they can just go out, and this is very, very common in Texas in particular. They can just go out and say, I want to buy a wind plant, and they'll just put out a request for proposals from all the different wind developers or all the different solar developers, or maybe either, and say, bring us the cheapest one. So going back to this is sort of what you've seen, a little bit of interest, and it really skyrocketed last year. And a lot of this was around the expected expiration of some tax credits, the production tax credit and the investment tax credit. All right, I'm going to just kind of keep moving, get to this last part here. Transmission infrastructure is very important for utility scale power plants, solar, wind, conventional power plants as well. We're starting to see a lot more interest in developing new transmission infrastructure. In the West, there historically has been one large market, the California ISO, and a bunch of different small markets. And now they're starting to talk about grouping some of those together, both to improve transmission access. So there's a lot of solar, for example, in southern Nevada and, or Nevada, I've been corrected on that many times, and Arizona that wants to get into California. California has high renewable energy demand, and they need more transmission there, but they also need more market structure around that because right now it's kind of a clunky process. Even if they have transmission, they have to schedule it ahead of time, and Arizona is in a different it has a different grid operator than the California ISO, so they have to schedule it between their different grid operators, that sort of thing. So they're talking about combining this to a certain extent. It's an ongoing discussion. It's actually changed a little bit from where this is now, but basically what they're talking about doing is creating an energy imbalance market. That's what they're calling it. And that's just to say that when there's a bunch of solar over here and California has a bunch of demand, let's ship it over here. When there's a bunch of wind up here or wind in California or geothermal and there's more demand, say because of a heat wave in both Southern California but also Nevada and Arizona, let's ship it there. So that's an interesting process, and the benefit of this is it seems small, but obviously in the quantities that we're talking about with large regions like California, this little difference, this little reduction in the need for power is a substantial benefit. Lastly on transmission, this is and I apologize I don't have the source for this. This is from an ERCOT transmission analysis looking in particular at solar power, and this is really just to show how transmission relates to the potential for solar development. So basically what this is saying is these are areas where they think in particular there's going to be a lot of solar activity and there may be a need for some more transmission infrastructure. There's also a lot of oil and gas activity around here, so there's a mutual benefit there. But this is just to show that states like Texas, the West in particular, you're starting to see it in the Midwest where there's a lot of wind. They're really starting to get serious about transmission infrastructure. Okay, this is the last section, I promise. Thank you all for sticking with me, by the way. I know this is dense material. Well, maybe not. I don't know. Maybe it's just me. But this is, and speaking of, this is an incredibly busy chart. But what I was trying to do here is kind of show all of the different out-of-market regulatory issues that are likely to impact solar over the next several years. We've got the investment tax credit, which is a 30% tax credit on our cost to construct a utility-scale power plant. We actually have to finance that, by the way, through tax equity, there are a very small number of companies that are willing to finance using tax equity. They have to have a massive tax base to finance a $500 million power plant or even more expensive. And what that ultimately means is even though it's a 30% tax credit, the benefit to a solar power plant in terms of reduced cost is significantly smaller than that. Maybe 20%. I don't know what the exact number is, and it depends on the exact or on the specific project. So we've got this, and it's expected to ramp down over the next through 2021. And then when it ramps down completely, we'll be at a 10% investment tax credit, which is the same investment tax credit that a lot of other technologies and large manufacturing installations receive. Then we've got the Clean Power Plan. This is the EPA's greenhouse gas regulation. This is their major initiative. Hopefully some of you have read about it, maybe are familiar with it. This is, I think, going to have a substantial but difficult to detect impact on the power markets in general. The Clean Power Plan itself is not particularly aggressive. So it's not really going to change the trajectory we're on, in my view, but it will, I think, provide a lot of forward market stability. I've been in the energy industry since 2002, I guess, and literally the first 5 years that I was in the energy industry, I worked for a company, ICF Consulting, and I was doing modeling on cap and trade programs. So this discussion has been going on. This type of approach has been expected for 14 years now. And I think that has led to a lot of the hesitance that we see in making investments, in particular in coal plants, but also in any kind of power plant, because again, if we're a solar power plant and we frankly stand to benefit from the Clean Power Plan because we're a clean energy generator, we don't have any carbon dioxide emissions associated with our generation, that increases our value. But if we don't know that's going to happen, it becomes difficult to finance a project like that. At the same time, we've got some additional regulations, the Cross-State Air Pollution Rule, Mercury and Air Toxics Rule, Ambient Air Quality Rule, or Ambient and Air Quality Revision on ozone, that a lot of these have just recently happened. These are all going to impact how existing conventional fossil-fueled power plants can operate in the market. So if you have, let's say, a lignite coal plant in East Texas, and you decided not to invest in an SO2 scrubber, and now you have to deal with the cross-state air pollution rule, which impacts SO2, you have a choice to make. And if say your power plant is sort of on the margin, it's not always the most cost effective, so it's not always running. Do you want to spend, I don't know how much an SO2 scrubber costs, what is it, like $50 million or something like that, depending on the size. You want to spend several tens, hundreds of millions of dollars to invest in major infrastructure changes at your power plant that is then going to have to deal with carbon dioxide regulation? Or does it make sense to retire your power plant? And that's a really tough decision. Every owner is going to have to make that decision for themselves. This is going to affect our market. So I think the general expectation is there will be some power plants that it's just not going to make sense to make that investment to upgrade them because they're already out of the market. I mean, there are power plants today, literally, in Texas that they only run them during what are called the peak months. So basically in the winter when the power prices go up a little bit because there's some electric demand for heating, and then in the summer where there's obviously huge air conditioning demand. They mothball, or they seasonally mothball them. So they kind of turn them off, use that time during the spring and fall to maintain them. Those are the power plants that aren't really that cost effective to run. So this is going to have a big impact. And this is just this is one of those things that if you're really interested, you can kind of dig into. But it just shows the impact of the Clean Power Plan, the required reductions in each state throughout the U.S. And the red number is the final number. So like for Texas, it's 33%. Which one? I can't remember which one's the worst hit. I think it might be Montana is 47%. They have one just massive coal plant. And, the way that EPA developed the regulations is unfortunately necessarily complex, but as a result of the way they did that, it's 47%. The benefit is, and what the EPA is allowing them to do, is develop trading markets with other states. So I think that's it. I actually made it to the end and I didn't run out of time. I'm kind of impressed. So I'm sorry if I plowed through that really quickly. I'm happy to answer any questions though. And thanks for your patience, by the way.
So I was interested in some of the life cycle environmental impacts of the manufacturing process, especially as it relates to maybe competitiveness against Chinese manufacturers that may not have the same level of environmental regulations on the life cycle. So do you see that becoming a bigger issue into the future?
Yeah, I think it will. Absolutely. I mean, as you know, I'm not very familiar with the Paris Climate Treaty. But as I understand it, I know that obviously China, India, the larger economies that are still growing at a very rapid pace have made some substantial commitments. At the same time, as different countries throughout the world try to emphasize reducing carbon dioxide, whether it's to meet their own internal goals or, for example, the Paris Climate Treaty, that is going to be a very important issue. Even probably more near-term impact is going to be for businesses and utilities, city municipal utilities, for example, that care about life cycle impacts. Google, Walmart, they care about these life cycle impacts. Right now, they're just trying to get to 100% renewable energy. In many cases, maybe it's 50%. Once they start getting there, they're going to start caring more about, well, how clean is this really, in a life cycle context? And I just have to put a plug in here for First Solar. I mean, that's obviously that 2.5 hours versus a day and a half. A lot of that is energy saved. So we're actually, and there are a number of studies that we've that universities primarily in Europe, because this has been a big focus in Europe, have done. Our life cycle CO2 impact is I wouldn't say substantially lower than another type of panel manufacturer, only because when you put it in the context of a coal power plant or a gas power plant, there's the difference is minimal. But if you're just looking at the two types of solar technologies, there's a pretty big impact. Yeah.
So I was looking at your transmission map where there was a heat map of solar and where the transmission was in West Texas. So if there's a lot of good solar there and there's no transmission, who should pay? And does First Solar consider that a form of subsidy if it gets socialized out somehow?
So first of all, there is transmission out there. There is already transmission out there. But there's probably a need to make some upgrades. And actually what you're seeing is a lot of that need is to meet oil and gas demand currently, which is surprising to me. But even though jobs are lower, rig counts are lower in the Permian Basin area, oil and gas demand is still substantial. And apparently, I don't know if it's growing at a rapid clip, but it is growing. Who pays is a tricky issue with transmission. I actually don't consider it a subsidy. I've thought about this a lot. It is a common carrier approach. I think if you look at any kind of market regulation where you have a common carrier, where you have substantial capital investments that are necessary for the system to operate and to serve the entire community that is interconnected by that system, those costs need to be paid by the system. And it's very, very difficult to assign costs appropriately. Whether you're assigning them to the end user, which is how Texas has developed all of its transmission historically. They've basically said, if we need transmission in Houston for the LNG port, which is happening, right? We're all paying for it. And everybody pays, they call it a postage stamp, everybody pays whatever, I can't remember what the rate is per mile or something, but it essentially gets pancaked across all customers in Texas. I'm a little bit skeptical that there are better approaches, but I know that people would like to see some better, more innovative approaches. I think there's, and Dr. Baldick, if any of you know him, he's a fantastic, brilliant guy, has to me at least, talked often about potentially deregulating and making transmission competitive. I think that's a very tricky issue. I think when you've got an asset like transmission that everybody needs access to, and you don't want to have multiple transmission lines following the same route, it limits your options. It's a tough question. It's a good question.
So in some of the states that initially had pretty high penetration of distributed and rooftop solar, I'm curious what kind of impact, if any, the rollback of net metering regulations in places like Nevada and Hawaii has had on the utility industry or for solar in particular.
That's a good question as well. And that's an important issue, and any of you that are interested in the solar industry and solar market, I highly encourage you to follow the net metering discussion that's happening in Nevada, Arizona, not so much in Texas because we have a competitive market and competitive suppliers decide, and some of them have decided to offer retail rates for customers. But net metering, just in case nobody is aware or somebody in the audience may not know, is essentially the mechanism by which a customer gets compensated for any excess generation from solar on their roof. And net metering typically says you get the full retail rate. So if you're paying 10 cents a kilowatt hour and you're putting 100 kilowatt hours back on the grid, you get the same rate. If you consume 200, then you save 200 kilowatt hours at 10 cents. And I'm sorry, I can't do the math in my head, and that should be super easy math, but it's just not my day for that. So if you do 200, if you consume it in your house, you save that on your bill. And if you export 100 kilowatt hours onto the grid, you also save that on your bill. That's presented a problem for utilities that are typically used to getting all of their revenue from their customers based on customer electric consumption. And so utilities have worked to roll this back throughout the U.S., particularly Nevada, Arizona. Those have been big issues. First Solar, we don't work in the retail, the residential rooftop space. And, I think that there is some validity to the concerns around net metering. That being said, the impacts that have, or the changes that have been made or proposed have had substantial impacts on rooftop solar in those states. They haven't really impacted our market as directly. It's not like we're seeing, in Nevada, rooftop solar markets dried up and all of a sudden they needed more utility scale solar. It's really hasn't happened that way, at least at this point, and I don't think that's really our expectation.
Well, he almost asked the same question I was going to ask.
You have a good one?
Huh?
No.
Yeah, kind of a follow-up question. So of course the reason they've been reducing net metering is a lot of those areas they see solar production peaking around the noon hours and then consumption peaking around the late afternoon hours. So do you see that becoming an issue as your utility scale solar starts to achieve greater and greater penetration? Do you see a need to counteract that in some ways, or?
Well, so utility scale solar operates in, whether, again, I mean, this depends on what kind of market construct you operate in. If it's a vertically integrated utility, what they would do, my expectation of what might happen at some point in the future is they might say, we're full up on solar. We've got a lot of solar. We've got a lot of clean daytime power, and now we need something a little bit different. Maybe it's solar with storage. Maybe it's more demand response. Maybe it's wind, what have you. In competitive markets, I think the conversation is a little more interesting. And I think one of the benefits of utility scale solar is that we operate in those competitive markets in a way that enables that transition very rapidly. So if you start to see utility scale solar taking up 10% of the power in ERCOT, you're going to start to see some sort of a price response as a result of that. Frankly, 10% of the power in ERCOT is not that much. And right now in most markets we're at less than 1 or 2%, with the possible exception of the Southwest. At some point that, again, for utility scale solar, not to be cavalier, but I think that problem is a little more easily resolved. But we have a long way to go before we'd even get to a problem like that. Yeah, right. Yeah. That's it is interesting. I don't know. There's got to be a bias in sociology, a term for this, but it's that sort of, oh wow, we're going to have 10% like next year, and no, actually it's 15 years away, and even though that's in your head, and I put it in your head, it's going to be a while, and we've got plenty of time to adjust.
I'll ask you a question. Some of those ERCOT studies that you said you weren't willing to talk about because they haven't officially released them yet.
Yeah.
They officially released them to the extent they showed what they've come up with so far without putting a stamp on it.
Yeah.
They're saying possibly 25 gigawatts of utility scale solar in Texas within the next 15 years.
Yep.
That's a huge chunk of power in an area where we're, currently 70, 75 gigs max?
Yep.
How are you all going to play in that?
I'm sorry, how?
How are you all going to play in that for solar?
So first I would say, and they're showing, I think, numbers even higher than that in some of their more extreme scenarios. That being said, yeah, it is a big chunk. And that's one of the reasons that we're very bullish on Texas. There are a lot of, in my view, maybe not a lot. There are a few substantial issues with the way the market is currently structured and operating that would need to be resolved to facilitate any kind of new generation growth. Natural gas, solar, wind are probably the most immediate choices for Texas just based on cost competitiveness. But if we're going to have a need, and those are, I'm not saying that the rules need to change. I'm saying that there are conditions in the market that will need to change. Maybe it's the retirement of old power plants that are no longer cost effective. Maybe it is some change to the rules. There are these, there's the operating reserves demand curve, which I didn't even think I was going to talk about today, which is basically it's an administrative mechanism that creates a higher, it kicks the price up when demand goes higher in Texas and when the reserves are lower. It's not functioning very well. It's really not providing the kind of price signal that I think the regulators intended. So how we're going to go after that, we are going to target sites that have great transmission access, that have kind of a low overhead, in terms of the landowner is interested in developing solar and willing to work with us. Maybe we're going to be going after contracts with commercial off-takers, with the Googles of the world. Mars just signed a big wind contract earlier in the year. So that's how we're going to go after it. How it's going to happen, I think, it remains to be seen. But I do think, again, maybe some power plant retirements change the market, and maybe some of these other market changes, the clean power plant, other things are going to have an impact as well. But if we want to continue to have a really functioning, competitive, deregulated market, I personally think that some other changes need to happen as well. I think there's a question back there.
Thank you. A lot of landowners here in Texas, they have they're setting it up to where they have the wind farms and oil and gas, and I think they're trying to do solar as well. Can you talk about the logistics or the challenges of getting solar? Where you already have wind, pretty much you have wind and oil and gas already set up.
Do you mean in like the same place?
Yeah, yes,
Okay.
sir.
Okay, so I don't even know, and I could be wrong. I'm not sure that there is that much of an effort to put wind power plants in the exact same place where they're doing oil and gas extraction. Is that what you're talking about though, extraction? I know that a lot of oil and gas developers that need electricity for their extraction processes are contracting with wind companies and wind power plants that are probably nearby. And so they're nearby. That means they don't have to go over as much transmission. They don't have risk of the transmission getting congested, which can increase their costs. But I don't know how much what I would call co-location is actually happening. Because just like for solar, for a wind developer, they want to find the best resource on the best land with the best transmission access. Same with solar. So oftentimes those pieces of land are very different for wind and solar. It's very rare, I think, to find a piece of land that works just as well for wind as it does for solar, or two pieces of land that are right next to each other. That's why we have the electric grid. That's why we have this transmission system. That's why we pay for the transmission system the way that we do, because it enables us to maximize the value of each type of resource with minimal cost. I hope that answers the question. I could be wrong about that, but okay.
I'll add a little something for you if you're interested. We, University Lands, have been working in oil and gas for a long time. And we've been approached by some of the oil and gas leaseholders we have on the university lands that are interested in putting solar on site. There's enough easement around the drill pads, there's enough easements on some of the lots where they would like to see solar, which is not dual use. I mean, when you put solar on the land, you're not going to do much else with it, but there's sufficient there that they would like to see the solar literally on site to feed their demand so they don't have to necessarily buy as much off of the grid. So there is some interest in that, and it is doable to some extent, because most of the oil and gas leases, if you look from above, when you fly over those lands, you see how it's structured. There's a lot of empty space that is available and unperturbed and available for that.
Yeah, and I'll just add one more piece onto that, because it's an interesting issue. I mean, we have, we're developing solar projects on land where there are oil and gas leases. We have a project, Berea Solar out in West Texas. It's a competitively contracted. We don't have a long-term contract. We just sell it onto the open market. And in the process of developing that, we had to work with the oil and gas leaseholders to essentially arrange our power plant in a way that provided them with access to the minerals that they would need whenever they would want it. And that's easy to do for the most part because solar is so modular. Sometimes it can be difficult to get the oil and gas companies to, I guess, sort of come to the table because they're just not as familiar with solar. I don't want to say that they're opposed to it or anything, but they're focused on their business and they don't really want to, focus on ours as much. And I totally understand that. But yeah, it is. That is a good opportunity, I think, for working together. And I think it is rare, but a great opportunity to take advantage of when you can co-locate.
On the subject of transmission, ERCOT has its heat map showing the most promising solar resource in Texas, and most of it's out in West Texas. Some of it's, I think, co-located with some of the wind installations out there, but a lot of it is also just sort of out in the middle of nowhere. Mm-hmm. So if we're going to get the 25 gigawatts of solar, or utility-scale solar that ERCOT is apparently projecting, what kind of infrastructural improvements will it take for us to get there? And will that require ERCOT just kind of building out on its own, or will it take working with some utility-scale solar companies as well? So,
well, first, and I'm going to speak to, in the current, the upcoming long-term system assessment, ERCOT does what I would call their base case, a current trend scenario. And in that scenario, they show 20 gigawatts being built, I think, somewhere around that number. Of that 20 gigawatts, I want to say 4, maybe 7 gigawatts. I think it's 4, actually, are far west Texas. So that's an important thing to realize. I mean, when ERCOT is looking at these numbers, they're actually showing a lot of, and I think this is further down the road when the cost of solar panels and solar development comes down further, they're showing a lot of development closer into load, in the Dallas-Fort Worth area in particular. So first of all, the need for transmission is certainly not as extreme as you might think if you were to expect 20 gigawatts to be built, you know, in a particular county in West Texas, for example, or something like that. And because of that, to answer your question, because of that, I think that most of the transmission needs are going to be addressed incrementally over time as demand, as load, feels that need. Again, primarily maybe oil and gas, but there's also, I think, like iron foundries. Is that right? There's other large industrial loads out in West Texas. So I think that transmission is going to be developed incrementally through the standard transmission process. And what that looks like is a transmission company, a transmission and distribution provider like Oncor, for example, will look at the next 10 years, what they project for load growth over the next 10 years, and they'll say, okay, well, we think there's going to be a lot of demand in this region. And at the same time, we know that there are a couple of solar companies that are looking to develop in that region. And maybe they have projects already, maybe they don't. But if we are able to, maybe it's build a new line, maybe it's add capacity on an existing line, maybe it's adding capacitor banks and stuff that I don't really understand. But if they're able to improve the transmission infrastructure there on that one, because of that one particular need, then that will just go through the normal process. And that's actually already starting to happen. Like I said, with the Permian Basin transmission expansions, the board just recently approved the construction of a 138 kV line at Berea Junction near our Berea power plant. And again, that was to meet industrial load. So I think it's smaller than people might think, even though the growth of solar is going to be big. I think the sort of transmission need can be addressed incrementally over time. Man, this is like the corner over here.
So I was interested also in your views on property tax abatements. So I know about the development in Texas of wind and solar projects that take advantage of school district tax abatement policies. How important are those in you making the business case for development, first of all? And second of all, what are the detrimental impacts from the lost revenue for school districts?
So it is going to be a little outside of my field of expertise. I haven't spent that much time on the finance side of it. I know that we actually make the schools whole, as part of that I can't remember what the agreement is called, payment in lieu of taxes agreements generally. As far as I understand it, there is no real detrimental impact to the schools. I may be wrong on that, but we make them whole as part of the agreement. And if they don't want to agree to that, they won't, obviously. They're not required to give us that tax abatement. One of the things that's most interesting to me has been the opportunity to learn whether it's important or not. And looking at our sort of pro formas, our financial modeling, one of the great things about utility scale solar, but also one of the, as a person within a company, one of the things that kind of makes you feel like maybe you're a little bit too much on the bleeding edge sometimes, we have very thin margins, and that's great for the customers. So a tax abatement like the Chapter 313 tax abatements, for example, they actually make a big difference and they can make or break a project. Which is kind of surprising to me because on a project by project level, it doesn't seem like a whole lot of money, but it actually is pretty big impact on the cash flow of the project.
I think we're kind of running out of questions here. Thank you all for coming, and Colin, especially you.
Thanks a lot.
For talking to us, and join us later if you like to.